Yes. Now, welcome to today's class. Today, I have prepared for you a very nice area that is in probability, and specifically, I want to show you how you can get mean and variance having been given the MGF. That is it. Now, consider the MGF, that is MT, being equals to 1 minus T beta raised to negative alpha. How can I get mean and variance? First of all, remember, before I get variance, I need to get mean. So let us see how we can get mean first, is when I get variance. So we shall start with the mean. Now, to begin with the mean, remember that you need to recall that mean is being gotten by the first derivative of the MGF. Very, very important. You are just supposed to come and get the DDT of the MGF. And the MGF, the function is this. So just get DDT of this. That is it. So you come here and write that the DDT of the MGF is MT. And this one we have said that is the same as DDT of, that is 1 minus T beta raised to negative alpha. Yes, so that's my first step. Now, after that, you just need to see a way in which you can work out the first derivative of 1 minus T beta raised to negative alpha. Now, remember, under differentiation, you come up with several ways in which you can work out some of the differentiation problems, like we came up with something to do with chain rule. So remember, on a chain rule it states that I need to be having dy dx, but here I have t. So I can say that let my function of mt be y, and the function inside, that is 1 minus t beta, be equal to u, so that I get by dt, which is the same as dy du dot du dt. That is it. So I'll come and say here that by chain rule, so by chain rule, it states that I need to say let the empty be y, and the function inside the bracket be u. So, and 1, remember the function inside the bracket is 1 minus t beta be u, so that from here I can now get my dy du as, how can I get dy du? Remember, you can, from what I've written here, y is the function of mt. And what is the function of mt? It is 1 minus t beta negative, that is negative alpha. So these are, the whole of this is the function of mt. That is it. So when I say that let it be y, and I want to get my dy du, and what was u? U, remember, was that is this one is u, so this one is y, sorry. Then this one is u. That is very important. Therefore, I can get dy du. Dy du, what does dy du mean? You just write the function of u. And before I write this, let me show you how I can write the function of y du. Y being equals to, y is the function of mt. What is the function of mt? Function of mt is 1 minus t beta raised to negative alpha. So the whole of this is my y. That is it. And what is the function inside the bracket here? This one is u. So when I write u here, then I raise with negative alpha and mean the same thing. So I'll come and say the function of y shall be, that is u, because it is u, the whole content here, because that is u, the whole of that, raised to negative alpha there. That is it. It is very important to understand this, because by the time I shall be getting dy du, this is what I shall be differentiating, and it shall be very simple for you to go through it. And therefore from here I can get dy du being equals to, I just differentiate the function of y with respect to u. And therefore, how can I differentiate this? To differentiate this, you are just supposed to come and say that the whole of this function should come at the preceding term, such that you have negative alpha, then remember, after bringing it here, you need to subtract 1 from the power, and therefore it is negative alpha minus 1. Very, very crucial and important. And therefore, since u I am having, I can now go further and substitute where u is. I just substitute it with what was it. Remember, u was 1 minus t. So I can come here, back here and go further and say it is now negative alpha into now, that is u. And what is u? 1 minus tb. So it is 1 minus tb, but u is raised to negative alpha plus minus 1. So I just raise it, that is negative alpha minus 1. And I shall have just finalizes with the dy du. Now after that, you need to come up and get du dt. Very, very important, because chain rule states that I'll be getting dy dt. And therefore, I need to be knowing du dt. Now let us see du dt. So du dt now shall be, now to differentiate the function of u here, that is 1 minus tb, with respect to t, it just states that I need to differentiate a constant. When you differentiate a constant, probably is a 0. Then when you differentiate negative tb, you will end up by having negative beta only, because this t you need to subtract 1 from the power, and you will end up by having 0 as the power, and anything raised to 0 is 1, which will not change the negative of the beta. Now after that, I can now use that is the chain rule that states that it is dy dt, which is equals to dy du dot du dt. And what is it? This one is the same as my dy du is already here. Remember, dy du is here. Then my du dt is here. So I just take this and multiply with the factor. Of which this negative will cancel this negative, and we will end up by having alpha beta. So that is alpha beta into the function here. That is 1 minus t beta negative alpha minus 1. Now, after coming up with this one is what we are talking about as our dy dt. Now, having gotten this, you are now supposed to come up here and say that let t to be 0. So when t is 0, meaning you just come where t is, just substitute it with 0, then write the remaining result. And therefore you will come up and say, now let us begin here. When t is 0, so let us put 0 here. So 0 by b beta is just 0. And therefore 1 minus 0 probably is 1. 1 raised to anything is probably 1. And therefore you will just end up with alpha beta. So you come up and write alpha beta as your answer. You will have gotten the mean as that gotten there. After that, having gotten the mean as that is our alpha beta, we also framed as the first derivative of the mgf function. Remember, that is the mgf function, that is mt as this. Let us now go further and get the variance, so that you can see. And therefore, I'll come here and get the variance. Remember that variance of x, the formula, because it is very important to know the formula before you work out, so that the formula will guide you. What do you require? Now, variance of x, the formula states that I need to be getting that is the second derivative, that is x, minus the first derivative, then I square. Remember, the first derivative already I've gotten, that was the mean. My main task is only to get the second derivative. How can I get the second derivative? So therefore, I'll come up and write second derivative being equals to the ddx, that is ddt, sorry, that is the ddt of the first derivative. Remember, our first derivative I've gotten here. This is our first derivative. So just get ddx of it. So I'll come up here and write over the first derivative, that is probably alpha. Remember, we've gotten that is alpha beta. So alpha beta into 1 minus t beta. Remember, 1 minus t beta. Then it is raised to negative alpha minus 1. So I need to differentiate this function. Now let us see how you can differentiate that function. Now to differentiate this function here, remember I have the first part and the second part. Meaning I'll be using product rule to find the derivative of the first part and the second part. Now when I look at the second part here, it will require me to use a chain rule to solve this. And therefore it is better to begin with the second part by differentiating it, so that by the time you shall be coming up to the second part, you just substitute it there. And therefore let us get, that is ddt of this second part, that is 1 minus t beta raised to negative alpha minus 1. Now how can I work out this? To work out this, you just use the same formula. Remember here I can use chain rule. So I just say that by chain rule it states that I need to let the whole of this function to be some letter like y. So let me just say let the whole of that function, remember it is t beta negative alpha minus 1 be y. Now after letting it be y, the whole of the function, let us let the content within the bracket to be u, so that it will be so and 1 minus t beta be u. After that, I can now come and say therefore y is equals to, substitute the content here with u, so it will be u raised to negative alpha minus 1. After coming up with this, you are required now to get that is dy du, then you get du dt, then now you get dy dt, and you shall have just learned with the part of the chain rule. So you come here and say that dy, therefore du is now the same as, you just come and differentiate this function here. Now let us see, to differentiate this, you are required to bring the whole of this content here. Then you subtract 1 to the power. That is the inclusion. And therefore it is negative alpha minus 1, the whole of that function there. Then it is u. I just write the power the way it is, but I subtract 1. So that is negative alpha. I need to subtract 1, which neg 1 minus 1 is neg 2. So I'll come up with the negative 2. And remember, I can as well substitute u with what was it. Remember, u was this. So where u is, why don't I write the content that u represented? And therefore, I'll finalize by saying that it is negative alpha minus 1 u, and u is 1 minus t beta. So 1 minus t beta, but it is raised to negative alpha minus 2. So negative alpha minus 2. You will have gotten dy du. After that, you need to come up and get now du dt, so that we use chain rule. So therefore, du dt shall now be, let us see, du dt, you just come to the function of u and differentiate it, let's see. When I differentiate is 1 minus t beta. When I differentiate a constant, it is just 0. So here I will be having 0. Then negative t beta, when you differentiate with respect to t, you will end up by having negative beta. So that is negative beta as your answer on du dt. Now after that, I can now come here and write my chain rule, that is dy dt. For this case, I will not write the formula because we've seen the formula on the first part. That the formula says that I need to get dy du dot du dt. Meaning, I just take this content negative beta, then I multiply by the content here. That is it. And when you take negative beta by the content here, probably you will end up by that is negative beta into the whole of the content, that is negative alpha minus 1, then I have 1 minus 10 beta, the whole, everything is raised to minus 2. That is it. Now after that, you can, so far so good, you can solve, that is this bracket here, or you can as well even leave it the way it is. You can solve it or you can leave it. Now, remember, that was this first part, and therefore now I can use product rule now to finalize the second derivative. Therefore, I'll come up and say that by product rule, my m2t now shall be, now come here. Remember, the product rule states that since I have two parts here, you first differentiate the first part while holding the second part constant. Then you now hold the first part constant, but you differentiate the second part. That is it. Now let us see. First of all, let us now come to the first part. Let us differentiate the first part with respect to t. Remember, we are differentiating with respect to t. Now let us see. When I differentiate the first part with respect to t, that is alpha beta, it will be 0. Therefore, when I hold this one constant, I'll end up by having everything 0. And therefore, you need to add now later, because the first part is 0, there's no need of writing 0 here. So let us go to the second part. The second part states that I need to hold this one constant, that is alpha beta, but I differentiate this. And remember, already I have differentiated this by so doing it here. Remember, the whole of this, I was differentiating this. And that is the answer. So instead of rewriting that, I need to be writing this. That is that. And therefore, I'll come up here now and say that it is negative beta. I can solve this bracket, the first bracket, that negative beta by negative alpha. Negative goes and I remain with alpha beta. So that is alpha beta. Negative beta by negative 1 is just beta, so that is plus beta. Then I write the whole of this 1 minus t beta negative alpha minus 2. Now after that, having gotten the second, that is the second derivative, you need to come in up here and say t to be 0. Where t is in this function, just put 0, then get the final answer. Let us see. T is 0 here, so when I write 0 here, 0 by b is 0, so I'll come up with 1 minus 0, which probably is 1. 1 raised to anything, we'll say it is just 1, and therefore it will not change anything here. So this one is my second derivative. So I'll come up here and say that is alpha beta into alpha beta plus beta. That is it. And so far so good. You can go further and simplify that. There is no tax. You can as well come here and solve this bracket here by saying alpha beta by alpha beta is alpha squared beta squared. So that is alpha squared beta squared. Then alpha beta by beta is alpha beta squared. So that is plus alpha beta squared. So you will end up by having your second derivative as that. Now after getting that, you can now come and get the variance, because already you know the second derivative, you know the first derivative, and therefore you can now get the final answer by so saying that var x is now equal to m1 m2t, which is this, that is alpha squared beta squared plus alpha beta squared minus, remember our first derivative we say that it is alpha beta, so this is what we write, but I square it because that's the formula. So when I square alpha beta, it is alpha squared beta squared. Remember, I have alpha squared beta squared, alpha squared beta squared. They cancel each other, and therefore I remain with alpha beta squared. And then one marks the final here, that is alpha beta squared as my final answer. Having done all that we've done so, you will have gotten both mean as well as variance of the MGF. Let me meet you in the next class. Otherwise, share the video to as many of your friends as possible. As well, subscribe to receive more notification. Otherwise, let me meet you in the next class. Bye.